So what are we talking about? Sequences and series. What's the difference between a sequence and a series? Sage. He's saying sequences are a bunch of numbers with a pattern. Yep. Or not a pattern, correct? And the series is when we add up those terms within a sequence. Okay? And the two, there's a whole lot of different sequences that we can look at. Like you can have squared patterns, you can have whatever. We are just going to be looking at arithmetic and geometric. So how can we define an arithmetic sequence? It is arithmetic, same difference. And there was one little thing you had to remember when we were trying to find what that difference was. Do you remember what we talked about? How do we find the difference? I mean, most of you can look and suss the difference. Hello? Yes, Matthew?
Take the first term from the second term.
Subtract the first term from the second term, that's right. So T2 take T1, and we know that that represents second term, first term. Agreed? The general formula for a sequence is? I saw you look down there, but anyway. I mean, these were just flashed at you yesterday, so I'm very impressed with what you're remembering so far. Ooh, well done. Yep. What did we multiply by? Times the difference. Okay, so Tn, that's referred to, that is just your nth term. And if you didn't get this down last lesson, this is where I would recommend you've got that 1 page of notes or a booklet, whatever. What did we call the A was? First term, great. Okay, n is obviously, you'll see that's the term that we want. So if I'm talking about the 5th term is, well, that would make n 5. And of course, D was for your difference. The skills that we're going to do in working all this stuff out is the way of thinking, I guess, is going to be pretty much the same when we look at geometrics. We're going to set this up and you can go on your merry way to do a whole lot of different questions. You will also find somewhere within the work that we're doing, it's going to remind you about simultaneous equations. So we will remind you about how to solve those algebraically, as well as using our beautiful collators. All right. And it starts off very number, then it's going to go into some worded questions. Are we pumped for this? Good. For those playing at home, we will be doing these today, and I just said try and look at the Cambridge questions because they are written in a slightly different version, and it's good to have that experience because, again, when I write your tests, that's somebody else writing in a different form. So the more questions you can do, the better off you are. And clearly, there's 20 questions there, so even though I've said 9, 10, 11, you can go and do as many as you want. And may I just remind you, these are from the Cambridge methods, right? Go to one of your tabs, you've got the text there, and you download and make sure it's there because we've all got the hard copies in the school. And hopefully we'll start geometric. All right? So I hope you're happy to skip a few of these questions, so decide whether these sequences are arithmetic or not. How would we suss it? 15 take 7, is that the same as 23 take, and so on. Did we do these yesterday? I think we did. Right. State the first term and the common difference. So we can call that T1 or A, but first term and so on. How would we get the common difference? Once again, 9 take 5 is 4, 13 take 9 is 4. Like, please. Believe it or not, some people stuff up D. Why? Yes, they just, whether it's first lesson back or what, but just watch your negatives. And 3 is all about just forming a formula. Ooh. Maybe once we do this one, you can go back and maybe do 3F. I forgot that one there. It was nice. So, shall we do question 4 together, and then I might send you on your merry way, and we'll see how you go. You probably don't even need me to do question 4, but I like to feel useful. So hopefully we've got today's date. You are labeling your work really clearly because I will check that you have done the necessary work. So we can see stuff nicely. So notation, notation, notation. So A, show that the sequence is arithmetic. What do we have to do for that? Yep, so you can't just look and go, bleh. We have to have just a little bit of a, so 17 take 6. And I might even be bold and go 50 take. Right, making it clear, you are showing the marker, the reader, you know what it means, that it's a arithmetic sequence. Right, another, I don't want to pick on you, David, but David might go, same difference of 11, therefore arithmetic. He might not want to write all the numbers down. David likes to keep things simple, correct? Yep. And I'll say again, I totally believe that you could do this without me, but, you know, we're just saving a little bit of time by doing it together. Just putting the aircon on. So, find the formula for its general use to avoid any mistakes. Pretty simple. We are going to say we need A. Do we know what A is?
6.
Easy. Do we know what the difference is? Yes, we just popped it before. So, therefore, we want to find this formula. A plus N take 1 times D, so sub. It becomes 6 plus N take 1 times 11. (11 times N). I like to have my letter at the front, my pronumeral at the front, and then we've got 6 take 11. You happy with -5? Great. And there is our general term. Yes, my friend. Did I stuff up?
No. I just put an extra step.
You can put an extra step. I'm just having to bend and I want to keep it all on the board. Correct. If you want to write 6 plus 11 and take 11, put that extra step in, by all means. Obviously, what would you say if I said do all of C, D, and E? Well, yeah, sub, because they're all the same question. Would you agree? Just different N values. So which one shall we do? In the middle? Yeah, D in the middle. All right, so if we were doing D, again, I'm a bit of a, not so much a suck-up, but I like to have everything there. So I would probably write N equals 325, okay, and we're writing therefore the 325th term, so 325 will just be 11 times 325 minus 5. Don't hurt your heads, plug it in your calculator and away you go. Yes?
The question on the 325th term, is that different to
Member term, same thing. So they're trying to just show you. Oh, sorry. Oh, I lied. Apologies. Going too fast. Sorry. Oh, and that's all on video too. How rude. I just thought D, and E were the same. Bad Ange. Okay. E. Sorry for you writing that down. Apologies. I can feel them frowning at me. So, if you don't need to write this bit down because I think this is incredibly obvious. So the 50th term, that would be 11 times 50 take 5. C. Right, D is 325 a member, so I'd like to say I set that up properly to show you. You must read the question carefully. but I just did not, so sorry. All right, so is 325 a member or not? So we're going to slap 325 in there, right? We will solve for n, but how will that tell us if it's a member or not?
If it's equal.
Well, I mean, so the answer was, they said if it's equal. I mean, I can solve this and I can get any value for n.
Integer.
Right, n has to be an integer, a whole number, right? So, Dev, sorry, we wrote this down yesterday and I forgot to add in here, but that needs to be, can we remember the notation for this, what that meant? So, n is contained in the set of all positive values. So, this just means positive whole numbers. So, basically, if you solve for n and you get a decimal, it's not in the set. It's not a member. Make it the sense? So, $330, so n equals E, but what do you predict? It's going to be not. I reckon you're going to solve for E and n will be a non-integer and therefore you'll go not part of the group, not part of the sequence. Does that make sense? Sorry, I'm just going to flick up again. You'll find that a lot of the stuff is repeat. There's just some negative numbers in there sometimes. And sometimes the words are written a little bit differently. Okay, so let's see how you go. I'll be quiet and I'll just move around. How does that sound? Has everyone been able to grab this file? Leo, I'm going to come and add you to the group. Yep. Question 8. A recursive formula, it just means you're using the previous term in that formula. So if you have a look here, you've got Tn plus 1, it uses the Tn, so that's the previous term. So all that's saying is to get the next term, take that first term and add 1. So by definition, add 7. Because you are adding 7 to each term, it has to be arithmetic. Does that make sense? If you really wanted to go hardcore on this and prove it for everyone, if we look at Tn plus 1 equals Tn plus 7, the next term would be Tn plus 2 equals Tn plus 1 plus 7. Would you agree? So technically what we could say is this was the n plus 2 term. This is technically the previous term. Would you agree? The difference. So you could say t to the n plus 1 plus 7, take the previous term, take the previous term, which is t to the n plus 1, and we get that difference of 7. It's a bit, so don't worry too much if you can't. How do we work out the process of recursives? This is not what this question is asking, but I'm just showing you what's going on. So if we were to find T1, they've told us that that is minus 12. So that's basically when n equals 0, because 0 plus 1 gives you the 1. Agreed? So now the next term would happen when n is 1. So now we've got the second term, right? I'm using our formula that they gave me. N is now 2, so now it's got, sorry, n is 1. I've now got n is 1 plus 7. But what was T1? So then that's minus 12 plus 7, which is minus 5. Ooh. And then the next term, T3, well, that's going to mean when n is 2, so that will now be T2 plus 7. What was T2? And so on and so forth. Bit of a pain in the gluteus maximus. What's the difference? 2, take, 5, 7. Minus 5, take, 12, 7. Zeb.
Is there a quicker way to do that?
Well, as you notice, they're not... Yeah. So, thank you. So, doing this continually, I don't want to keep doing this to get to the 200th term, agreed? But from this, do we know what our first term is? First term then is, negative 12. We know that the difference is 7. So what would you do? As Sage said, you would find the general term and then away you go like the other ones. And just to make sure, is everyone happy with how do we find or know that something is a member of the sequence? You do what? Solve for n and ensure that n is not just an integer, a positive integer. Yep, integer whole number. Good. Are we happy with everything so far? Yeah, sorry, forgot to record, but maybe you can have a look. I'll save this on OneNote. Anyway, while we're here, two of these little concepts so you can work on it for homework. It's going to be, I think, was it 38 degrees on Sunday? So inside, in the air conditioning, get some maths done. Find K. Find K given that these are 3 consecutive terms. Remind me, consecutive means? Right, whoops, one after the other, after the other, after the other. So all in a row. Now, consecutive is key. What's the other key word there? Arithmetic, right? Because we might be doing a different sequence. If it didn't say arithmetic, you would be in strife. What does that mean then? Or how could we work this out? If they're consecutive and they're arithmetic, they have the same
difference.
They have the same difference. Yes? How does that help us? There's all K's everywhere. What could we do? Elliot, what can we do? We could say this, take this, has to equal what? You finish that off for me. K minus, so I want to say this minus this. What does it have to equal? That minus that. Do we agree on that? So, but watch what I'm doing. So K take. Bad. I'm making a face, but you can't see it. Am I good? I'm not good. How could I make this good? Well done. Yes. Girls at the front. Ella. Brackets. Now, you could, let me just finish, and then you could have done that, or you could have gone straight into, because you're minusing everything. So most people have the gist, but sometimes they make a silly error because it's a Friday, because they're chatting to the person, there's a bird out the window, who knows. But to make sure that you know what's going on, maybe, as soon as you see this, maybe you're just writing what's in your head. Same diff. Not only will it help you, but it will also, if I'm marking your work, anyone else marking your work, they go, oh, let's be a bit more sympathetic. We know they know what's going on. They just made a whoopsie. Whereas if you don't put that, sometimes it's not clear. Does that make sense? Start putting down a little bit of your thinking now. Is this now something that you can solve? Absolutely. It's linear. Get your K's on one side, non-K's on the other. Sweet. Without ruining your surprise, the need to be surprised, some of the ones that you're going to get, what do you see with E and F? Ooh, there's a squared in there. What does that mean? Not exponential. Think the Queen. Quadratic. How do you solve a quadratic? You want everything on one side, right? Someone said the quad formula. Sure. I'd like to think you could probably factorize it, but again, it's first week back. You're doing it on a hot day over the weekend. What else could you use? Hold it up, Ella, hold it up. You could use your calculator, graphics calculator. Do we remember? Do we remember how to solve a quadratic on the calculator or not? Equation, polynomial, degree 2. Okay. Shh. If you forget that, put a little star and we will go through that next week. I would like to remind you about this one. Give you a moment, read it, have a think. In time, you have all the knowledge and the skills to solve this. This was what I would be saying is an unfamiliar question. And things like this hopefully will crop up in methods and in spec. You haven't done anything like this, but there's the attitude where, well, what is something that we can do? You can't find the difference. Oh, maybe you could. That's T. Let me do. We've got T3 is 8 and it's arithmetic. Would you agree with that? So as soon as it says arithmetic, we're going to go I'm also going to write down, I'm getting rid of all the words and all the white noise and I'm just focusing. Now when I see this, I've got a couple of bits of information here. What is the 3? That's saying n is 3. Do we agree?
Yeah.
And what is the 8? That's basically, it's not A. It would only be A if we had n was 1. So we don't know, but wouldn't this be your term? So sub. I'm going to end up then with 8 equals, I don't know what A is, plus, did I know what n is? So 3 take 1, I get 2D. Oh dear, 2 unknowns. If you have 2 unknowns and only one piece of information, you've got infinitely many solutions. If only there was a second bit of information. Is there a second bit of information? Yes?
Couldn't you just do 8 plus 5d equals -17?
You could do, you want to go 8 plus 5d equals -17. They're starting you off very nicely here because you're going to end up with, 31st term is blah, 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 and crazy. And you could try that. So when we've got this one, T8 equals -17, we're going to do exactly the same thing. We are going to sub. So we get -17 equals A. What is my n?
D is -5.
8 take 1 is 7D, correct? When they're smaller numbers, you can solve. I'm telling you, this is when they're bigger numbers. So I've got 2 equations with 2 unknowns. How do I solve it? Simultaneous equations. Now, these are pretty easy, right? You can just pop this one straight under. The A is always going to cancel out because there's always going to be 1A. Do we agree? 7D take 2D, we get the 5D. The A's cancel. What's -17 take 8? And therefore your difference is -5. What did you say it was?
-5.
You did not. You said 5.
I said -5.
Did you?
I have it right here on my page.
Oh, he's so good. I apologise. Matthew. I would say your last name, but it's on video, so I will not. Okay. How do we then find A? Slap it back in. We? Simon, Matthew, you're lovely. Okay, so they get a bit more crazy. but it's just simultaneous. We good with that? If you want to write that down, you can. There is an example there. It doesn't say algebraically. You could use your graphics calculator, but would you agree that by the time you get to your calculator and type in, this would have been quicker? Because there's always going to be a single A.
I think my way.
Yeah, sure, okay.